So in this video, we are going to be comparing two different population proportions, also known on the graphing calculator as the two proportional z-test. Now we're going to use this when we have two percents that we are comparing against each other. What isn't obvious inside of this problem here is it's not just blaring that this is a percent problem, but it actually is. Let's do our step 0, which is reading this information and show you how it's a percent problem. So there are two types of medication for hives that are being tested to determine if there is a difference in the proportion of adult patient reactions. So this is supposed to reduce the amount of hives that a person gets when they have a hives outbreak, okay? So what we're going to find is these medications are really effective, but we're trying to see if there's a significant difference between the two of them, of people who still have hives after 30 minutes. Because it says 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. So that's actually pretty great, because 180 got rid of their inflammation. And so the step 0 here, we're going to talk about medication A, and the X of A, which is the number of people who still had hives after 30 minutes, was 20. And our N of A, which is our total, which is 200. Now we're going to look at B here, because it says 12 out of another random sample of 200 adults given medication B still had hives after taking the medication. So this is X of B, which is 12. Okay, so that's a lot lower, but is that significantly different? So this is our N of B, which is 200. Okay, so what you're not really seeing in this is the actual percentage. All right, so what I'm going to do is I'm going to actually find this P hat of A. Now, P hat is our percent chance if you took medication A that it wouldn't have any effect after a while. So to get P hat, you just divide your X and N. Okay, so the P percentage chance of having no effect after 30 minutes is going to be dividing your 20 and 200. So your P hat of A is 10%. So you have a 90% chance of having good stuff with this medication, and 10% chance that you'll still have hives after 30 minutes. Okay, so let's look at B. Let's figure out P hat for B. And the P hat for B is going to be taking your X and dividing by your N. So this is 12 and 200. Okay, 12 and 200, if you divide those two, you get 0.06, which is really great. I mean, this medication was 94% effective according to this study, and only 6% still had hives after 30 minutes. Now, you might be curious, why do we actually need this P hat and the B hat? And you'll find out why in step 2. Now, sometimes the story problem gives you the X and the N, like this one. But as you see at the end of this video, in the third example, they give you the percentages, and then you have to figure out the X and the N. Similar to what you did in homework assignments earlier in this section. So, let's go to step 1. Step 1 is to talk about the null and the alternative hypothesis. The null hypothesis is pretty straightforward to write. You can pretty much see that we want the probability of A to be the same as the probability of B. Like, there's not a significant difference. Even though you can see that 10% and 6% are literally different, are they statistically significantly different? So now let's go to the alternative. The alternative here now is going to be C here, determine if there is a difference. So therefore, the P sub A is not equal to the P sub B. Okay, so what do we do for step 2? In step 2, we have to check to see if both groups here have their N, P, and Q greater than 10. This is a rule of thumb that if this is true, then you can assume normality. So let's do group A on the left here. If we do group A on the left here, our N was 200, our p hat was 0.1, and our q hat is going to be the complement of p hat, which is 0.9. And 200 times 0.1 times 0.9 is equal to 18. And 18 is greater than 10, so congratulations, we can assume normality from that group. Now let's try the other group. This is group B's N, P, and Q, and we want to make sure that's greater than 10 as well. Well, we have 200, we have 0.06, and we have 0.94. And that gives us a total of, when we multiply these three things together, 11.28, and 11.28 is greater than 10. I mean, not by much, but it is greater than 10, and therefore we can assume normality. All right, which means we can continue on with this test. Okay, so in step 3, and 4 and 5, we're going to let the calculator do the work here. Turn on the calculator, click on the stat button, and click to tests. So we move 2 clicks over to tests. Now here we need the 2 proportional z-tests. So this is option 6 on my calculator. I'm going to hit enter. And what's nice about the way that the story problem was written is it pretty much hands you the x and n in the exact order that you need it for the problem. The x was 20 and 200 for the first group, and the x was 12 and 200 for the second group. This is a reminder that if the problem gives you percentages, you're going to have to figure out your x from the problem itself. This gave us x, so now what we will do is easily click the p sub 1 is not equal to p sub 2, and we're on to the drawing portion of the problem. Should have a nice two-tailed test on that z-curve, and the z-score is 1.4744, and the p-value is 0.1404. So it's time to put this on the screen. So z is equal to 1.4744, and the p-value, which is different than p hat. This is the p-value. This is the percent chance of you landing in this event. This is the p-value to determine if this is a rare event or not. Again, not to be confused with p hat for the group 1 or the group 2. Then what we have is our normal curve, our beautiful z-curve here with 0 standard deviations away from no difference. But according to our flag, which we're going to plant at 1.4744 standard deviations away from the norm, or in this case, you were 1.47 standard deviations away from no difference between these two groups, but it looks like you were off a little bit, which means you had a 14% chance in landing either that green zone or that green shaded zone. So this is when we're going to do our little, decide on which group is, bigger than other. So our p-value was 14.84. Our alpha was 0.05 because that's our test. And since our p-value, our percentage chance of it landing inside of this zone, was greater than our chance of making a mistake, we do not have sufficient enough evidence to say that they're different. So take either medication. Take the one that costs less on your insurance, because since the p is greater than alpha here, we do not have sufficient information. We do not have sufficient evidence. Evidence is the word I used. First of all, let's write sufficient evidence to reject the null hypothesis. Okay, that is the first of 3 problems we're going to do. And now we're on to the second problem, where they're going to be even better for us, where they're just going to lay everything out in a table. So this second example is going to be a little easier. We're going to research the gender differences in sexting. The researcher believed that the proportion of females involved in sexting was less than males. So we're going to use this data, and it's all presented here in table form. And we're not going to have to do anything in step 0 other than maybe finding out the p-value. So let's do that. Let's find the p-value for the males. And the p-value for the males is going to be 183 divided by 2,231. and that is going to give you 0.08. Okay, that's the p-value, or I should say the p-hat value of the males, so the q-hat would then be 0.92. Let's do the p-hat for the females, which is going to be 156 divided by 2,169, and that will be 0.07 for the p-hat for the females. So you can see that these percentages are really close. Now, again, the research study was continued, and the researcher believed that the women were less. Excuse me, the women. It says here, the researcher believed that the females were did this less than the males. So that means our null hypothesis is going to be males is equal to females. Whoops, not mu. Sorry. It's going to be p. Our p of m. That's p hat technically, but p sub naught is, we're just going to put p sub m here, is equal to p sub f. And our alternative is going to be p sub m is greater than p sub f. Okay, because they think, again, according to here, that the proportion of females involved in secting is less than the proportion of males. So that would make the males greater than females. Now, step 2, we're going to do our quick test here of n times p times q. And let's do that. let's make that look a little nicer. Let's do this for our male group, which is the 2,231 times the 0.08 times the 0.92. And this gives us an answer of 164.2, which is definitely greater than 10. So we're good there. Now let's do our n times p times q. See if that's greater than 10 for the other group. So 2169 times the 0.07. Parentheses would probably be better here. And then 0.93, because that's the complement of 0.07. And that's going to be 141.2. All right, so both of these are well covered. We have big enough sample sizes to take care of this. Because as you've seen in previous examples, it's not just good enough to say, well, it looks like our sample size is bigger than 30. Okay, so here we go with another proportional z-test. Click on Stat, move over to Tests, move down to 2 proportional z-test here. And in this case, again, the males easily given in the chart, 183 and 2,231. And women also given in the chart. It was very nice that the chart was given to us just like that, 156 and 2169. Then we get not P1 equal to, or not equal to P2. In this case, we think the men are greater than the women. So click on that third option here. And then we go to Draw. And we have a right tail test. And we have a z-score of 1.2565. Excuse me. And we also have a p-value of 0.1045. So, what does that tell us? Well, first of all, let's write down our z-score. And our z-score is 1.2565. And our p-value is 0.1045. We're going to have our beautiful z-curve, and we're going to have a right tail in this direction here along the bottom, and it looks like we're going to plant the flag here at 1.2565 standard deviations away from no difference between the two groups. And we knew that 1 was, within the realm of normal, like a normal group, but now that we're beyond 1, we definitely need to check the percentage. This says we had a 10.45 chance of checking the percentage, and this is the closest call here because we're doing a p versus an alpha. The alpha was 10%, the p-value was 10.45%. If you move the decimal over twice, well, this is bigger, but man, is it just, well, so close there. But since it is bigger, we do not have enough evidence to reject the null hypothesis. So since the p is greater than alpha, we do not have sufficient evidence to reject the null hypothesis. What's even more telling about this data here is that you could change the alpha. You'd have to change the alpha to higher than 10% to get us to reject the null hypothesis, but then you're kind of like, am I just adjusting the alpha beyond what is reasonable here? Because we really shouldn't be seeing alphas bigger than 10% here, because then you just might be, throwing you're just trying to affect your data, like you're just trying to say like, oh, I'm really hoping for this result. Don't adjust your alpha for the result. Set your alpha, take your test, and call it good. All right, let's not be dishonest here. Okay, so now in this last problem, this is a problem where they're going to give us the p values for these two problems, the younger and the older, okay? So we're looking at a study on smartphone usage. And I actually saw a problem similar to this in the book, and I went out to a website that had an article about how older people are kind of more inclined to use the iPhone than younger people. So I just literally took their data and their sample sizes, and I'm going to see if the article, is right in saying that. Because if they run the data and they find out it's not statistically significant, then that should be the headline. That, well, I guess it's a wash between iPhone users of older and younger people. So again, this is 2020 information, so it could change as things go on, but here we go. There's a cell phone company claim that iPhone smartphones are more popular with younger, below 30 people versus older people. So we'll work with a young group under 30, and then older people would be 30 and above. The results of the indicate show that, okay, so if we have young people here, that the N size of the young group here is 986, and 53% had an iPhone. Okay, so the younger people, sorry, I think I misread the problem at the start. It looks like younger people have iPhones and older people don't. All right, so let's keep on that with that hypothesis here. So the younger people here, 986, okay, and then 53%. So this is their P of Y here, okay? This is their P hat of their Y of this group is 53%, or 0.53. Now we need this information because we need to figure out our X value for this group because of the older group, okay? And the older group, so this is going to be N, and that's the letter O. I know it looks like a 0 there, but it's going to be N with the O, and this is going to be 1,357, and the P, now this is again an O, it's not a 0 here. This is P hat of the older group is going to be 0.46. Now we're going to test at the 1% level of significance, so that is going to be my alpha over here. And we're going to say, is the proportion of older iPhone users greater than the proportion of younger iPhone users? And it really should be less than, because the older users, you can easily say, have this. So we're going to change that to less than. And that will be fixed on future versions of this worksheet here, because we can easily see that older people have a smaller percentage chance. But is it significantly smaller? All right, so let's do our null hypothesis here. A null hypothesis is where my P sub Y is equal to my P, and then this is going to be my sub O. Okay, now our alternative is going to be my P sub Y is greater than my P sub O. All right, because that would then match, because it looks like younger people have 53% and older people have 46%. Now, what's nice about having the p hat and the of y and o is that we can do our NPQ greater than 10 very easily. So we're going to take our young people's sample size here, and then we're going to multiply that by 0.53, which is the p hat of our young group, and then multiply that by 0.47. And that gives us 223.2, which is greater than 10. Then we're going to do our NPQ of our older group and see if that's bigger than 10. And I think it is, because this sample size is a lot larger. I mean, the reason why these are bigger than 10 is determined by how big the sample size is. And this rule of thumb says if it's bigger than 10, we can assume normality. So here's 0.46, and the complement of 0.46 is 0.54, and that gives us 337.1. Again, this is over 10, so we can assume normality. Now, what we need to type into the calculator, though, is we need to type in our x sub y and our x sub o. Now, we can figure this out by taking our percentage, which is our p hat y, and multiplying it by our sample size. So this is going to be multiplying our p hat y times our n y. So if we're given the percentage, then we multiply by our sample, and that gives us the x, or how many people had an iPhone in our group of 986 here. So this is going to be 0.53 times 986, which is 523, and we're rounding up. We're always going to round up here because we're not going to have a partial person in this study. So round up, even if it was like 522.0001, round to 523. It was nice because this naturally rounded up, but we're going to keep rounding up no matter what. So this is my p hat o times my n sub o, and this is going to be then the 0.46 times our 1,357. And again, this is going to give us 624 and something. So let's round up to 625. Okay, always round up. So this gives us our n. This is our x sub y and our x sub o, because we need these for part 3, which is typing in the equation. So let's go to our calculator, and then if we click on here and we click on stat and move over to tests, what we could do is then move down to the 2 prop z test, and then we type in for our x1 our 523, and our n sub 1 was 986. Then we type in our 625 for my x of the older group, and then 1,357. And again, we want another greater than problem, and we're going to click on draw. Okay, now here's something kind of interesting. You have this graph that looks blank, but let's pay very close attention to the z and the p value here. Okay, so let's write down the z value. The z value is 3.3391 standard deviations away from 0, and the p value, not to be confused with p hat, the p value was 4e negative 4. Now this is not 4%. This is actually 4 times 10 to the negative 4th power. The e stands for exponential notation. So it means move the decimal 4 spaces to the left. So we have our 4.0, and we move the decimal 1, 2, 3, 4. So this puts 3 zeros in front of it. So this p-value is in fact 0.0004. Okay, which makes our p-value very small. So we have this curve. So what is the pixels are not fine enough on our graphing calculator. So when we plant our flag at 3.3391. You can't even see the shaded zone, but there is a shaded zone where our chances of landing in that shaded zone is 0.0004, which is highly unlikely. So the p-value is a rare event. It's more rare than our 1% that we tried to like really hone in on this alpha here. So 0.0004 is less than 0.01. So we're going to reject the null hypothesis that younger and older people like the iPhone equally. That is wrong. We are okay with probably moving with our premise here that younger people like the iPhone more than older people, since P is greater than, P is less than alpha. There's our wonderful inequality that we need for our paper pencil work. We have sufficient evidence to reject the null hypothesis. Yep, we have sufficient evidence. Should probably just highlight the we part of this here. We reject the null hypothesis. Well, thank you for watching and seeing some of the different kinds of problems we can have with a two-sample proportional z-test.